This question comes from Ian, and many others, who asks, suppose you did drain the Earth's oceans and dump the water on top of the Curiosity rover. How would Mars change as the water accumulated? In the previous What If, we opened a portal at the bottom of the Mariana Trench and we let the oceans drain out. For fun, we drained them to Mars. The Curiosity rover is working so hard to find evidence of liquid water, so I figured we could make things easier for it. There is a lot of water currently on Mars. The problem is, it's mostly frozen. Liquid water doesn't last long there because Mars is too cold and there's too little air. Before we inundated Curiosity, its temperature sensors recorded air and ground temperatures ranging daily between minus 100 degrees and 0 degrees Celsius, with the ground occasionally getting a bit above freezing. Here's the phase diagram for water, and this line represents the average atmospheric pressure on Mars, which by coincidence almost perfectly intersects the triple point of water. It's technically possible for liquid water to exist on Mars at the very lowest elevations on warm days, since low elevations have higher atmospheric pressures, but on most of Mars's surface, water either stays frozen or sublimates directly from water ice to water vapor. But the oceans we're dumping onto Mars wouldn't freeze solid anytime soon. We're dumping a lot of water very fast, and Mars isn't that cold. The average temperatures at the North Pole on Earth range from minus 30 to 0 degrees Celsius, and only the top layer of water freezes, because ice is a decent insulator. Plus, the oceans are saltwater, and salt makes it slightly harder for water to freeze. Here's an elevation map of Mars. Currently, Curiosity is sitting in Gale Crater, a round depression in the Martian surface with a peak, nicknamed Mount Sharp, in the center. We're dumping a lot of water very fast, which will start to turn Gale Crater into a lake, just like it would on Earth. As the flow continues, the lake fills in, burying Curiosity under hundreds of meters of water. Oddly, the water would freeze from above and below at the same time because the Martian surface is also below freezing. Rocks and soil would almost certainly become frozen together into ice-dirt chunks that break free and float up to the surface like icebergs. Eventually, Mount Sharp becomes an island surrounded by ice-covered water. However, before the peak can disappear completely, the water spills over the north rim of the crater and starts flowing out across the sand. The water flows downhill to the north and pools in the North Polar Basin, while a layer of sea ice and rockbergs forms on top. When this kind of water release happens on Mars in real life, the trickle of water quickly freezes and sublimates before it can get very far. However, we've got a lot of ocean at our disposal. Gradually, the water will fill the North Polar Basin, covering the defunct Phoenix and Viking landers, unless they also get caught in freezing ice and lifted up to float on the surface. If we look at the rest of Mars, we'll see there's still a lot of land far from the water. I'm a big fan of maps. I've spent a lot of time drawing them and just looking at them over the years, and I have to say, I think this one's kind of boring. It's just this big empty swath of land with some ocean on top. Luckily for us, if not for Mars, we haven't come close to running out of ocean yet. At this point, the water fills in the Valles Marineris, creating these unusual coastlines here. The water and ice now reach the other Mars landers, carrying them south. Eventually, the flow breaks through into the Hellas impact crater, the basin covering the lowest point on Mars, and Perseverance is likely destroyed in the ensuing ice rock waterfall. In my opinion, the rest of the map is starting to look pretty good. Like, check out that crinkly coastline. Like, this is a nice map. This is the kind of map where if it were in the front of a fantasy novel, I would spend a lot of time looking at it and trying to decide where, like, my kingdom would be. The swath of land in the southern hemisphere splits into several large islands and innumerable smaller ones, and also looks very nice. Just A+, excellent map. The water quickly finishes covering most of the high southern plateaus, leaving only a few islands left. And then, at last, the flow stops. The oceans back on Earth are drained, and the rovers all have water damage and are now probably out of warranty. Olympus Mons and a few other volcanoes are still above water, and they aren't even close to being covered. Olympus Mons still rises well over 10 kilometers above the new sea level. The oceans on Mars would last a very long time. The surface of Mars is already at least 2% ice by weight, and that ice gradually gets transported to the poles by sublimation and atmospheric circulation, but it's an incredibly slow process. We're covering the planet with an enormous amount of ice-topped water. The ice would get thicker and thicker as the water below it cooled, and eventually the oceans would freeze solid. The surface would very gradually sublimate away to the poles, and if the ice had picked up enough dirt and rocks, they would be revealed and collect on top, like how dirt collects on top of a melting snowbank, until perhaps eventually the equatorial regions of Mars would become a dusty, rocky surface atop a bedrock of ice. Except maybe none of this would happen. Water is a potent greenhouse gas, and with so much new water available to evaporate into the atmosphere, maybe Mars would warm up and the oceans would remain liquid as they are here on Earth. There's only one way to find out.